Sitting on the southern part of Yangon, Dala keeps the original rural characteristics and single agricultural production because of the less development during the urbanization of Yangon. Moreover, various water-related issues put more pressure on its future development. The existing social formation of Dala is monotonous. Unlike the other part of Yangon, there is no large factory in Dala. Large amount of land is used as rice cultivation, and the rice is delivered to the other part of Myanmar for post-processing. The simulation uses the water discharge data of Cyclone Nargis in 2008, which helps us to understand large-scale flooding pattern of extreme weather in Dala. Due to the topography, the riverbank of Yangon River keeps the water away from the urban area, but the water flows from both sides of Dala. It shows that the lower part paddy field is vulnerable to be flooded. Large area of cultivated land is damaged and caused loss by flooding. In order to understand the sediment and erosion of the river, the sequence shows the new water runoff is created after the sediment and erosion happen. This is considered as a guideline for the design. The territory is divided into several zones, which is based on different topography, scale, and distance to their context. Fish farm locates in the edge of the territory and is used as a buffer zone to decrease the impact of potential flooding. Transportation node is surrounded by productive zones and urban area. It connects the whole area to external part of Yangon with train or waterborne transport. Provoking a new organization of hybridizing existing urban space with the strategy of water, it offers a diverse program and resilient production that will revitalize Dala. The process of design of the urban scale is basically started by identifying the area affected by water morphology from simulation, mainly by three levels: dry season, wet season, and flooding. Based on this, main network and new urban, including food industry area, follow the media axis of the top of the watershed and form the new urban pattern. The paddy field occupies the lowland, which provides the most productive cultivation. Agroforestry is placed mainly on the bank of the potential water level in wet season. Agroforestry is an integrated sustainable land use system that combines agriculture and forestry, simultaneously creating ecology that improves productivity. It makes variety of agriculture to the area. Also, it could function as a windbreak and for stabilization of water edge. Biological filtration will be placed in between the water reservoir and agroforestry, which also functions as filter against the release of wastewater from the urban area. In order to improve the performance of the system, sediment will be highly used for increasing the elevation of topography. Interference structure will be plugged into the expected land and catch the sediment over time. So, based on the final outcome and water-land relationship, different programs will be corresponded to each typology. The exploration of the intervention I decide to implement raises up the question of possibility to stipulate the guideline policy for specific territories facing flooding, extreme weather which led by global warming, able at identifying alternative strategies in the use of the ground, and foreseen a territorial approach that offers spatial initiatives simultaneously. We ask ourselves if existing urban planning and top-down policy would cope with the specificity of these territories so much weaved together with man interventions.